My name is Kristian Strommen. I work for the University of Oxford as part of EERIE.
My name is Meike Scherrenberg and I work at the Dutch Environmental Assessment Agency in The Hague, the Netherlands.
My name is Gerrit Versteeg. I'm from the Netherlands, but now currently I'm working at the Barcelona Supercomputing Center.
My main role in EERIE is in work package 7, focusing on how the ocean mesoscale affects the atmospheric mean state and the variability of the atmosphere, in particular in the mid-latitudes and places like Europe.
I work on trying to investigate the consequences of climate change.
I'm working in a very interdisciplinary team of knowledge producers, knowledge integration actually, that works together with climate services. A storyline can be as primitive as just someone developing a good script, a good narrative story.
So we have climate change and we have certain scenarios in climate change. So for example, you could have an AMO collapse or certain tipping points. And to me, a storyline is how you start from an effect in the climate system to how this will impact society.
My understanding of a storyline is simply that it's a description of a possible future world, essentially. And in particular, not just any old description, but a description which helps people understand what their actual day-to-day lives are going to be like in this future world where, some amount of global warming is happening.
To me, it's for how we can really see how climate change affects society itself. Because we have these really great climate simulations, but what does it mean for us? What does it mean for society? What does it mean for the next decades?
The kinds of things climate scientists often work on, they're not very relatable to average people. So for example, we think about global warming of 2 degrees or 3 degrees or 1.5 degrees, and these numbers don't really mean much to people on the street. Or what does 2 degrees actually mean for me living in a particular country? How's my life going to be changed?
Basically trying to simplify, not so much dumb down what we're doing in our scientific work, but simplify it enough that it becomes a way of also being able to influence the public or any other non-expert target audience that you might have.
So if we want to know what happens to society, and for example, I specifically look at the crops, I need to know what happens to the temperature, what happens to precipitation, do we get more droughts? Or some people also look at, for example, damages because of floods. So what will happen if we have extreme precipitation? And this is data that we need, and this data is supplied by, for example, these climate model simulations.
You need to bring in non-climate scientists, essentially, people who are working on things like changes to mortality, changes to crop yields, changes to economic output, and so on. So people who aren't themselves necessarily climate scientists, but who work on kind of these more tangible impacts, and then bring all these people together and link it up with the simulations.
If we see a particular storm like the one in Valencia, we want to know what would have happened if there was no climate change, or what's the human contribution in this. So for me, it's also that it's so easily applicable to be used in some sort of attribution framework, for instance, which makes it more accessible to non-experts. The South American one is about climate-sensitive disease outbreaks. So there are specific, for example, mosquitoes, which depend on the amount of water that there's present. So for instance, if there's like a flood being generated, there might be more mosquito activity, or certain rats might be more exposed to human contact. From precipitation, you can put this into an impact model and then try to see whether you will have more people getting dengue or getting malaria, if there is any correlation in this sense, and maybe at some point even be able to forecast this.
Due to climate change, there might be more droughts, and these droughts will cause more crop damage. And because of crop damage, we will need to grow more crops to compensate this loss in crops. So that will cause more land use, that will cause more emissions. So this is sort of how a storyline might reveal itself.